Hello class, in today's presentation we are going to get introduced to the concept of the revolved object. We'll start to make this bottle that's on a board, and we will start making a bottle by first making a center line. And the center line will go from the coordinate origin and will be vertical. And I'm going to make the height of this center line like the total height of the bottle, which is in this case, what did we put here? 23 inches. So I'm going to put that this is a 23 inches. We will need a center line because that will be the axis of symmetry around which we are going to revolve our object. Now, we are going to make the rough outline of the body of the bottle by using rectangles, and we will just do the half profile. So the idea is that we make a profile which will sweep around, and based on the dimensions we know that the diameter of the body of the bottle is 10. So this is what I will do. I will click on a smart dimension, I will click on a vertical line of my rectangle, and I'm going to click on the axis, somewhere on the axis, let's say here, and pull the line in the opposite side of the sketch of the rectangle. So look, my rectangle is on the right hand side, I pull the dimension number on the left. And look what happened, it automatically infers relationship that this is a diameter. And I can dimension it now as a diameter of 10. Look, it says D2, and I will say that this is a 10 inches. And here is our 10-inch diameter. Now, I'm going to specify the height of 20 inches. And now I'm going to make the two other smaller rectangles at the top for the neck of this bottle. And actually I can extend a little bit center line to be a 24 inch so that I have something to pick. Going to make another rectangle here. I'm going to constrain the height of this rectangle to be a 2 inch. And I'm going to make another rectangle, and I'm going to make the dimension, the width, the diameter of this rectangle, and the diameter is what the outside diameter is 2. And then the top one for the will be another rectangle. And the diameter of this profile, again, I click on this, I click on the line, and I click on a center line, pull on the opposite side, and that diameter at the top is what? It is a 4 inch, so I will put a 4, and the height is a 1 inch. And that will fully define my outline of the bottle. Do you see a bottle now? Like kind of a width of half of the bottle. Going to close this sketch. Sketch is fully defined. Now, because I use those diameter relationship and I use the center line, it will kind of prefer revolution. So let's see what we have option: extrude and revolve boss. So let's click on a revolve boss. So left click on a revolve boss, and it automatically pick up my axis of revolution as a line 1. And now it asks me for how much I want for a 360 degree, what will be the full circle, and to select the contours. So I will left click on the rectangle of the area which says select contours. And now I will select this contour, and this contour. And look what we got. We got like a big cylindrical piece which is full of materials. If I click on this icon here in the middle of the screen, that's called the section view, you can see that this is really full of materials. However, we know from our specification that the bottle is going to be what? Thick 1/8 of the inch. So let me first define the material here. I'm going to right click and use ASI 1020. And if I do the evaluation of the mass properties, the bottle as is, so wow, it's 453 pounds, like this piece that we have right now. So let's continue building it. I will turn off my section view. Next thing that I want to do, I'm going to put the outside radiuses. And I have a specification that all of my fillets are 1/2 inch in radius. So in the content of the features, in the content of part building, I will click on a fillet and I will specify that 0.5. And I'm going to click at the bottom edge, at the top edge, this edge here, at the inner edge, outer edge, and this edge here. Click OK. And here is filleted bottom. Okay. Now, I still want to make it, now this is still not really a great bottle, because why? It is still full of materials. Now the question is, I have a uniform thickness. Do I need to mess up and to do something like a revolve cut, or to really figure out how to do a very complex sketch with using offsets? Or is there a way, how can I hollow that bottle out? The truth is that there is a way, and that option is called the shell. So we are going to find a placed feature, which is called shell, and it is here approximately in the center in the bottom row of the icons. So if I click on a shell panel will open, and in the shell panel it asks for a parameter, and the parameter of the shell is how thick that wall is going to be. And I say 1/8 of the inch. Now, I have to choose on the object on a screen. I have to choose a surface which I want to remove. That will be like opening of my bottle. That's at the bottle neck at the top. So I'm going to click on this blue area here, and I'm going to choose a surface which I want to remove, where that shell will be open. That will be this one here. And I don't have a multi-thickness. So let's see what will happen when I click OK. Look what happened. When I clicked OK, can you see it, that it is now hollow? Well, let's click on a cross section. How about this? Is it hollow? With a thickness of a 1/8 of the inch. So it's hollow. And now let's check if it is a hollow, what will be our mass? Mass property. Wow, so now this big metal bottle is only at 28 pounds, although we started with a 450 something pounds block object. So the revolve command, in a summary, should always use when we try to build something that have a central axis of symmetry. And if we try to build something that is hollow, and doesn't matter if it is with a uniform thickness or with a semi-uniform thickness where you have a discrete areas with different thicknesses, instead of messing up with a very complex sketches, the most convenient and the most robust model, the most model which will be easiest to modify, will be to use the shell command. Just remember, in the shell command, we always need to choose the surface that we want to remove. And if we don't choose anything, it will shell from inside, but will not remove anything. It will be like, let's say, making like a basketball. Now you want it to be hollow inside, but those objects are practically impossible to manufacture, the completely hollow inside object. Or you need to use some special techniques, like, for example, rotomolding. That's how balls, for example, is made. So, okay, so well, this will conclude this demonstration.